In this exercise, we are going to experiment to measure the cross-sectional properties of the cross-section, and the cross-section that we are going to create consists of the parabolic portion, so you will also learn a new sketch command for making a parabols. This is from the vector mechanics from engineer's problem P5.11. Coordinate system is originated in a center, so we are going to make the parabola vertex with 3 meters high and 4 meters half width of the parabola. So we will start sketch, and we can do it on a front plane to have the global x and y properly oriented. We can start by making a center line out. We need to be in a MKS as we are. And let's put that this is a 4.5 meters. This is a giant cross section, so this is probably like some earthwork cross section. .5 meters. Now we are going to make another one to which we are going to anchor the parabol. This one is going to be a 3 meters high. And now we are going to place, there is also a center arc or a circle which we can place there, and then do the trim later on. Radius of this circle is a 1.8. 1.8 meters is radius, what means diameter is a 1.8 times 2. 360. And now let's place that parabol. And before we place a parabol, let's make also the center line on the left hand side. And this center line is also 4.5 meters long. So this defines the basic geometry. Now to make a parabol, you will click on a figure of ellipse, what is here, and you will select parabola. And we are going the first point to place somewhere alongside this axis. Second point will place aligned vertically. And then we are going to just stretch parabola randomly. Press escape. Now we can move the point, grab the point, move it to coincide with this. This point we will move to coincide with this point. And the point on the top of the parabola, we will move it to coincide with the end point and to add. However, here is the one that does not like it, so the one that we need to get rid of is this one. And it will be a perfect fit. Here is a fully defined sketch. Now to complete this, we need to close the cross section, and we will need to do some trimming. And now let's trim the circle. And here is our cross section. Now the best way to be sure to evaluate this thing, if we click on evaluate, you have an option sectional property, and as you can see, this has already provided us with the sectional properties. This here thing what we see is the centroid of our cross section. Centroid relative to the part origin is here, and then moment of inertias at the principal axis LXX and LYY at the centroid, and moment of inertia at the centroid, and moment of inertia at the principal axis. So let's see now if we have polar moment of inertia here. Now let's see if we extrude it. We can also get the sectional properties of faces. Let's extrude this piece. Doesn't matter for point 1, let's say. Now to evaluate the sectional properties on the face, go to evaluate sectional properties, and you need to pick the face. And let's pick this face, and you will say recalculate, and here are our sectional properties for the face. And this here section is in a relationship to the global coordinate system. So this is the moment of inertia in a relationship to the coordinate system from here, from our global. And those are principles at the centroid. And you can see that they are the 860 and 6870 EX and IX and IY. We can also get the surface area, and we can get the coordinates of the centroid. Right, so this will be all for this recording and for the sectional properties of materials section. Very simple to use. You never need to use again the Steiner theorem. Just draw the proper cross section, select it either as a sketch or as a face. That concludes this presentation.